How do we solve inequalities that contain absolute values? Really, all it is just putting together what we know about solving inequalities and solving equations with absolute values. So let's get started. The absolute value of x is less than 5. So if we think about it, we know, just to do a quick sketch to illustrate what's going on, the absolute value of x, that function just looks like that, right? So we're looking for where that function is greater than 5, right? So if 5's a line like that, a horizontal line like that, the function is greater than 5, sort of in, let me get the highlighter out, sort of in this region here, right? It's greater than that line of 5, and here. Now, if you understand the absolute value function pretty well, you can probably see what the answer is going to be right now without doing any calculation. But if we follow the similar process as we did in the previous page, basically what we're doing is we're breaking this up. Oops, let me switch back to the pen. We're breaking this up in two cases. When the thing inside the absolute value function is greater than 0, and when it's less than 0, right? And when it's greater than 0, we know it's just going to be x is greater than 5, right? Just the positive side of that. And when it's less than 0, the negative version of that's going to be negative x is greater than 5. So to solve these equations, now this one's already solved for us. This one here, 5 goes on the other side, or sorry, the negative goes on the other side. We can just divide by -1. But when we do that, we have to also switch the sign, something like that. So right away, we can check, first of all, we can do our check to see if these solutions fit within these restrictions, and they do, right? 5 is greater than 0, -5 is less than 0. So we're okay with those restrictions right off the bat. And it basically just tells us what our answer is, right? So if we wanted to write this in set notation, all we got to do is x is an element of real numbers such that x is, we'll do the small one first, x is less than -5 and x is greater than 5. There's our solution, which makes sense because this line has a slope of 1, right? Has a slope of 1 and a slope of -1. So x is going to be 5 at a value of 5. Right? Or y is going to be 5 at an x value of 5. So it makes sense that it's on the outside of that. So there's our solution. Not too bad. Okay, on to the next one here. 8 minus x is less than 15. So this one's already simplified for us. So we just got to break it up into our positive and our negative case, right? Where 8 minus x is less, actually let's start off with greater than 0, and 8 minus x is less than 0. So in the positive case, we have positive 8 minus x is less than 15. And in our negative case, we have negative 8 minus x is less than 15. So if we solve these two equations, we solve the one on the left, the positive one, is just going to be x, or negative x, I should say, is less than 15 minus 8, which is 7. So that means x has to be greater than 7, or -7, sorry. So I divided by -1 or multiplied by -1, and I had to flip the direction of the sign. Same thing on the other side. So if I move that -8 to the other side, it's going to become positive. So 15 plus 8 is 23. And we have positive x. There we go. So x has to be greater than -7 and less than 23. So, oh, and we can check our values too. Does -7 fit in this range? Does it? It does. It's gonna, if we plug in a -7 here, it's gonna work. And also we can check it here. 8 minus 23 is definitely gonna be less than 0. So it actually does work with our restrictions as well. So we can just report now that our final answer, so it's gonna say, actually I'm gonna write it on a number line first. If this is our number line, it says it's greater than -7 and less than 23. So it's going to be between these two values. And it's not inclusive, right? Because the question has just a less than, not less than or equal to. So we can write in set notation, we can write our answer is x is an element of real numbers such that -7, x, 23. X is between 7 and 23. There's our answer.
Moving on to example C. Give this one a shot yourself. Pause the video here, try it yourself, unpause to see the solution.
So here we go. If you do this problem,
you will see, first of all, it's already isolated. The absolute value is already isolated. So if you break it up into the positive and negative cases, you see right away that the two solutions are x is greater than a half or x is less than negative 3/8. Before just accepting these as your final answer, first of all, they are going to be overlapping ranges, so we can think about what that means. But before actually accepting them as your final answer, we have to check. Remember, let's check to see if 1/2 and negative 3/8 were actually solutions to this problem. They fall within the correct range. If we do that, we see that 1/2 actually works. So if we plug in 1/2, it's going to give us a value of 3.5, which means that is greater than 0. So that is a solution. So we can give that a big check mark there. But if we plug in negative 3/8, we find that actually it does not give us a value that's less than 0.875. So it is not a solution. So we actually don't even have to worry about the fact that they're overlapping ranges. We just need to realize that the correct answer is x is greater than a half. And that is our final solution. So just to write it in set notation, x is an element of real numbers such that x must be greater than 1/2.